Imagine your phone isn't just sending pixels or data, it's sending meaning. Like telling a friend, this is a sunset, instead of uploading a 10 megabyte photo. That's the future of communication, semantic communication. But here's the catch. When devices like your phone, a drone, or a smart city sensor try to talk, they often speak different languages. Think of it like two people using different dictionaries to translate the same word. One says sunset, the other golden hour, both correct but confusing. This is called semantic mismatch, and it's a big hurdle for 6G networks, where billions of devices need to work together. So how do we fix this? Enter Reconfigurable Intelligent Surfaces, RIS, smart panels that act like mirrors, bending wireless signals to improve communication. Researchers combined RIS with a clever three-step, semantic equalizer, to align meanings before and after transmission. Here's how it works. 1. Pre-equalization. The sender tweaks its message to match the receiver's dictionary. 2. RIS-aided propagation. The signal bounces off smart surfaces, which adjust to keep the meaning clear. 3. Post-equalization. The receiver fine-tunes the message to decode it correctly. They tested two approaches, a simple linear method like a basic calculator, and a deep neural network like your voice assistant's AI. Both outperformed old methods, especially in noisy environments. But here's the twist. Neural networks, the AI powerhouses behind this, need a lot of data to work their magic. In experiments, a simpler method called linear equalization outperformed neural approaches when data was scarce. It's like using a basic filter versus a high-tech microscope. The filter works just fine if you don't need ultra-detailed images. However, when there's plenty of data, neural networks shine, adapting smarter to complex distortions. How does this align with real-world goals? Researchers are using latent spaces, abstract maps that AI uses to understand and compress information. By aligning these maps between sender and receiver, they can transmit data more efficiently. Imagine two people speaking the same secret code. They don't need to send every word, just the key phrases. This approach is super fast and reliable, especially in noisy environments. But here's another challenge. Traditional metrics like mean squared error, MSE, which measures numerical accuracy, might not always match real-world tasks. If a system scores well on paper, but fails to recognize a cat in a photo, something's off. Researchers now suggest weighted MSE metrics that prioritize task-specific goals, like image recognition, over pure numerical precision. And then there's Reconfigurable Intelligent Surfaces, RIS. Think of them as smart mirrors for signals. These surfaces don't just reflect signals, they shape them in real time, like a highway that reroutes traffic to avoid congestion. A 2024 study showed RIS can boost semantic communication by dynamically adjusting to user needs, making networks more responsive. Why does this matter? Imagine a future where your smart home, car, and city infrastructure understand each other seamlessly. No more dropped signals or misinterpreted commands. RIS acts like a cosmic traffic cop, redirecting signals to where they're needed most. And by aligning semantic meanings, this tech could make 6G not just faster but smarter. So next time you stream a video or send a text, remember, the future isn't just about speed. It's about understanding. And this research is paving the way for a world where machines don't just talk, they connect.